advanced D7E is about to start the bulk earth moving or rough grade cut, or rough cut. And equipped with the AccuGrade GPS system, it can achieve finished design tolerances of plus or minus 2 centimeters over the complete three-dimensional design. Now, if you look at your screens, you can see the in-cab display that the operator can see, showing the typical plan view the operator is using, where he can see the machine working within the road parameters. It also displays to him the cut and fill values left and right of the blade corners. Caterpillar AccuGrade on the D7E also has a unique feature called rough grading. This actually prevents the operator from overcutting the grade when working in the manual mode, and for bulk earthworks he can now work faster with the guarantee of not cutting below the final grade requirement. So we can now see on the screen the view that the operator sees in the manual mode. So when he's taking out the bulk earthworks, he's working in manual. The system is telling him where to cut, where to fill material. So you can see the cross-sectional view on the operator's display. The grey rectangle represents the blade. The red line actually is the project design cross-section. You can see, because he's above the grade, the figures in the left and right hand corner on the screen are in red. That's telling him he needs to cut more until he gets down to the grade. So as I said, he'll continue till he gets close to grade, and then he'll complete the final passes. He'll then perform them in the automatic mode by pressing one button on the control lever to automatically control the blade to follow the job site design. So now, done a couple of passes. When he's close to the finished grade, we'll switch to automatic. So you can see on the screen now we have the auto mode, and you can see the grey box. The blade is actually sitting right on the design file. So now in the auto mode, the system is controlling the hydraulic circuit. The operator just has to move the machine and move the material in the most easy, efficient way, but the GPS system is actually controlling the vertical position and cross slope of that blade. And as you can see, the values left and right are now green. That's telling him he's on grade. He's on the design. If he was to go below the grade for some reason, those values would change to blue in colour, which would tell him he has to now come back and backfill some material in that area. So the more accurate the bulk earthworks will be, the more productive the grader will be during the fine grading process. This will result in better material utilization. Being accurate for bulk earthworks can represent huge time and cost savings. Now, we've brought out the 345. This machine is also equipped with another GPS system, this time for excavators. The system consists of 2 GPS antennas, receivers mounted on the machine counterweight. It has sensors on the machine body, boom, stick and linkage. And for better protection, the linkage sensor is located inside the bucket cylinder. This is what we call the positioning sensing cylinder. A good example of how Caterpillar is integrating technology into the machine component design. Now, for excavators, this is an indicator system only. It provides only guidance. We don't actually automatically control the blade. So the excavator here, although he has the same design file in as the tractor, he's actually working on that 55-degree steep slope. It's too steep for a track-type tractor. He's actually using his monitor, again, that you can see on the screens right now. It's showing you the profile view. It's also showing you the cross-section view. So for the first pass, the operator follows the red line on the display in the profile view. And even if the embankment is curved, the operator knows at all time where his bucket tips are in relation to the finished grade. Once the first pass is correctly done, the operator has a visual reference on the ground and can be much faster for the next pass. A quick look at the light bars will indicate to the operator where the bucket tips are, above or below grade. Other applications may be trenching. We're digging a pipe trench. We can dig the pipe trench correct to the correct depth. We don't need any additional grade checkers or depth checkers, and or possibly if we're working underwater. Now, while he's working up there, this time we've brought in the D6T. We've brought that machine in to do the final shaping of the front embankment in front of the road. Like surfacing a golf course, the operator can quickly grade it without any stakes or external help. The machine again is equipped with AccuGrade dual GPS this time. It has the same receivers, the same display as the other machines. Component commonality makes the system more flexible if to be used on different AccuGrade ready machines. The AccuGrade ready option, which I mentioned in the first part of the demonstration, provides the integrated hardware pre-factory installed for very easy installation of laser or GPS. It's a real plug and play operation. So again, you can see the D6 this time working on the embankment in the front area in front of the road surface. So again, the operator is just taking care of the pushing of the material in the most efficient way. AccuGrade prevents mistakes and costly rework by moving the material correctly the first time. Fewer and longer passes make the machine more productive, also reducing your GET and undercarriage wear. Now our 14M is coming from the left hand side of the grandstand. This machine is equipped with Caterpillar AccuGrade UTS. UTS stands for Universal Total Station. This instrument automatically tracks the prism that you can see located on the top of the mast, which is attached to the machine moldboard. We've switched on the UTS from within the cabin of the motor grader. At the moment, the UTS is currently looking for the target. You can see the unit here in front of the grandstand. Once locked to the target, the UTS instrument continuously measures and computes the target's three-dimensional position up to 10 times per second, transmitting real-time data via a radio to the display inside of the cab once again. So the motor grader now is about to start the fine grading process of our road project. So combined with cross slope sensors, UTS calculates and shows the operator the position of the blade in relation to the project design, exactly the same way as the GPS system on the track time tractors that you can see here still working. So the UTS unit here should be tracking the prism on the grader, and as it's moving, it's calculating different angles, repositioning the blade automatically on the motor grader. Once again, you can see the